The last topic of this section that I want to cover is stoichiometry, and we usually talk about stoichiometry right after electrolytic cells. When we talked about stoichiometry in the past, we talked about it in terms of if you have this many grams of substance A, how many grams of substance B can you get? And you got to work through moles, right? And that is still the case here. We are worried about our balanced chemical equation when doing stoichiometry kinds of problems. So the first problem I have, I've typed out here for you. Notice that the 2, 4, and 3 in this chromium sulfate should all be subscripts. And what you should recognize from this is that the sulfate, of course, is a -2 charge. And if all the sulfates are -2, that means you've got a total of -6, which means all the chromium must be +6, which means each chromium is a +3. We're going to plate a faucet with chromium. Today we do it with paint, but we used to do it with chromium. And we're going to plate it with 0.86 grams of chromium metal, which means that the oxidation state of that chromium is 0. So we're going to start with chromium in the +3 oxidation state and go to chromium in the 0 oxidation state. So if we were to take a look at that, we are going to have this reaction occurring. Okay? Now it says plate a faucet with 0.86 grams of chromium from an electrolytic bath containing chromium 3 sulfate. What current is needed to do this in 12.5 minutes? If I want current, that means I need charge divided by time. I need coulombs per second for units or amps for seconds. Either one will work, right? And so let me start. I recognize first off that 12.5 minutes is going to be in the denominator because I need time in the denominator. Everything else needs to be in the numerator. So let me start with the 0.86 grams up in the top, and that's grams of chromium. And I want to convert that into moles. So if I look at a periodic table, I can find 51.996 grams of chromium for every 1 mole of chromium. And now I can use my balanced equation up above that tells me that for every 1 mole of chromium, I get 3 moles of electrons. Now that I've got moles of electrons, I can use Faraday's constant, which says that there are 96,485 coulombs for every 1 mole of electrons. Now I've got coulombs in the numerator. I need time in the denominator, so I'm simply going to put the 12.5 minutes in the denominator, and then I need to convert minutes into seconds, and for every 1 minute you get 60 seconds. So in terms of canceling out units, minutes are gone, moles of electrons are gone, moles of chromium are gone, grams of chromium are gone, and I'm left with coulombs in the numerator, seconds in the denominator, which is exactly what I need. This gives me a value of 6.4 coulombs per second. I could also, taking a look at that top reaction up there, an amp equals a coulomb per second. If I multiply both sides of the equation by a second, I would get an amp times a second is equal to a coulomb. And so since they are multiplied times each other, I could divide both sides by coulomb. And if I do that, I would get an amp times a second is equal to a coulomb. And now coulombs cancel, seconds cancel, and I've got 6.4 amps. And so you should recognize when doing these stoichiometry problems that you could basically be given any one of these things as an unknown. You could be given the grams of a substance as the unknown. You could be given how many moles of electrons are going to be transferred. You could be given the time as an unknown. You could be given the amperage as an unknown, right? So there's all sorts of possibilities. You just need to know what every other one of those variables is going to be in order to solve for the unknown. That's it for this section.